everybody, it's Miss Phoebus again, and here we're talking about the ancient Egyptian math, really their number system, and what it looked like. And I am actually going to ask you to try to draw some. So I'm going to include the slideshow where you see this video, so you can go back and you can look at what their number system looked like. So it's not like our number system, and it might be a little bit like the one that you created. All right, so the ancient Egyptians settled along the Fertile Nile Valley about 8,000 years ago, or maybe even earlier. We're not 100% sure. But they began to record the patterns of lunar phases and the seasons, both for agricultural and religious reasons. And ancient Egyptians were possibly the first civilization to practice the scientific arts. So chemistry is a word derived from the word alchemy, which is what ancient Egyptians used to call chemistry. So alchemy and chemistry come from Egyptian words. And Egyptians were really good at medicine and applied mathematics. So that means that things that they could touch and feel, so a lot of applied geometry and things like that. But there's a large body of papyrus literature out there that describes their achievement in medicine, but no records on how they reached their mathematical conclusions. So, ladies and gentlemen, this is what happens when you don't show your work. We don't know how things are developed. All we know is that they did math, they built some pretty amazing things. They did a lot of medicine and a lot of advancements in medicine that we do know a lot about, but we don't know that much about their math. So, of course, they must have had an advanced understanding of math because of all their engineering and astronomy and administration, being able to deal with large numbers of people, which is what the ancient Egyptians usually did. And so if they did not know how to provide that kind of structure for a whole bunch of people, they wouldn't have lasted very long. So the ancient Egyptians were very good at math. We do know that. I love their art and trying to see their hieroglyphics. I think those are pretty cool too. The pharaoh surveyors used measurements based on their body parts. So their palm, so that's the part of your hand that you usually hold things with, was the width of your hand, so they called that a palm. The cubit was a measure from your elbow to your fingertip. And then to measure land and buildings, they had to develop a decimal numeric system based on base 10, because we have 10 fingers. That's what they based it on. Okay, so ancient Egyptians, like their hieroglyphics, where they're very picture-oriented, their number system is also very picture-oriented. So 1 is very simple. It's a single stroke down, looks almost like a stick. And then 10 is a hobble for cattle. So this is like a structure that they would build to put cattle through. So to go from 1, you would need all of these lines all the way up to 9, and then as soon as you get to 10, you pick up a new symbol. And then if you want 11, you would have your cattle hobble, and you would have 1 next to it. And then when you get to 100, you would have, almost looks like an @ symbol, but I think it's more of just like a spiral there. And then with 1,000, I think I'm going to talk about it. Okay, so 100 is a coil of rope. 1,000 is a lotus plant, which I always think looks like it has a Pac-Man on top. I think that's what it looks like, a Pac-Man on a stick with a base. And then 10,000 is represented by a finger, a very long, skinny, pointy finger, according to this drawing. 100,000 is a tadpole or a frog. In this case, it looks more like a frog than a tadpole. And then 1,000,000 is the figure of a god with his arms raised above his head. Or, I mean, it looks like a man with like a ponytail standing straight up, but that's what it looks like to me, according to what I found here, that is supposed to represent a god. And so as you start building these numbers, you need more and more symbols to represent different numbers. So, however, there was not a concept of place values. So how you arrange the numbers don't mean anything. So larger numbers were rather unwieldy, although a million required just one character. A million minus one, which is 999,999, requires 54 things to draw. So this is where rounding would be very, very important, I would think, if I was dealing in ancient Egyptian number systems. So if we were going to write 3,244, we would have 3 lotus plants for the 3,000. We would have 2 of the spiral coil ropes to represent the 200, 4 of the cattle hobbles to represent the 40, and then 4 little ones to represent the 4. So 21,000 would be 2 of the long skinny fingers, 1 of the lotus plants, 2 of the coil ropes, 3 cattle hobbles, and then 7 of the ones to get all of that number built out. So I need you to go to your assignment, and you have 3 different numbers that you need to build, and you're going to draw those numbers on a sheet of paper. You're going to take a picture of them, and then you are going to submit those. And do your best. You're drawing a frog potentially, or a guy with his hands, making a touchdown, something like that. Do your best so that I can kind of make out what you're drawing, but you're going to not be graded on the quality of your drawing. So try to make sure that it is semi-good, semi-detectable what it is. If I can't tell what it is because you made up a new symbol, then yeah, we'll have some problems. All right, so here are your numbers that you're going to practice drawing, and they are in the assignment. So you could go ahead and draw them now and pause the video, and you've got everything right here. We also have some word problems, so we'll talk about those in a little bit. All ancient Egyptian fractions, with the exception of 2/3 and 3/4, are unit fractions, fractions with a numerator of 1. And for example, we're talking about 1/2 or 1/7 or 1/34. Unit fractions are written what we call additively. So 1/4, 1/28, if we wrote it that way with symbols, of course, remember the Egyptians are going to use symbols. So if I sat 1/4 and 1/28 together, that would mean that I should add them. And if I add them, knowing what I do with our number system, that would mean I would have 2/7. So I don't build a fraction that is 2/7 using special kind of symbols. I do it by creating the addition of 2 fractions that have a 1 on top. The hieroglyphic for R was used as the word part, and that looks like this little could be an ellipse. I think of it as like kind of like a skinny eye thing, like the eye shape, missing the eyeball part of it. And so you would see 1/3 as this is your part, and there's 3 ones there to represent that you're looking at part of 3. 1/3 would be 1 part out of 3. And then here we have our part, that's our R, and then we have our cattle hobble, which represents 10. So together they mean 1/10. So part of 10, we're just talking about 1 out of 10. So if I wanted, 3/10, I would draw 3 of those all next to each other, and that would mean that I have 3 of each one. So one of the ancient stories that the god Seth, the Egyptian god Seth, attacked his brother, the god Horus, and gouged out his eye and tore it all to pieces. This sounds terrible. Fortunately for Horus, the god Thoth was able to put the pieces back together and heal his eye. So in honor of this story, the ancient Egyptians also used the pieces of Horus's eye to describe fractions. So you have, in addition to the R that you can use, you have these additional pieces. So you have 1/2 is this shape, 1/4 is a round shape, 1/8 is like the top part of his eye, like his eyebrow, 1/6 is this other, 1/16, sorry, is this other part of his eye. 1/32 is like a curly Q thing, and if you ever see a picture of Horace, he like his eyes are like done up this way. I'm not quite sure why. And then he has this bottom piece that extends down, and that's 1/64. So 1/64 is a teardrop. I cried too, Horace. My eyeball got ripped apart. So these are all the different components of the eye and what they represent. So they bring some of the mythology into their number system. So you can then start kind of looking at building some other fractions. So they have 2/3, 3/4, 1/2, and so they have these other pieces that they start bringing into their number system. So here are some of our Egyptian mathematics. So a man borrows, number, well, remember the hobble is 10. So 1, 2, 3 tens. A man borrows 30 donkeys to use for transporting goods. To repay the loan, the man must give the lender, remember what that symbol is? That coiled rope. Each one of those is 100. So he's going to give 200 Devon, and Devon is a type of money, of copper every month per donkey. The man uses each donkey for, okay, we've got 10 here, 11, 12, 13, 14, 15, 16 days per month for transporting goods and earns 10, 20 Devon of copper per donkey for this work. How many Devon of copper does the man make per month? So he has to borrow things, he has money coming in, he has to repay. There's lots of stuff going on. So let's see if we can figure out what he makes per month. Well, we know that he's borrowed 30 donkeys to use for transporting goods. That's not important. Yes, he's transporting goods, but we don't need to know about the 30 donkeys. What is important, because we're talking about money that he makes per month, is our 200 Devon of copper. So he has to lose 200 Devon of copper.